is how you do this question. So we are looking at we're going to use, this is a circle theorem question. So we know, because we've got a chord here, that that the angle at the center is going to be twice that at the circumference. So we know that's 70. So if we do a little drawing of that, of this triangle, so ODA, ODC even, we know that this is 70, and so we know that this is 180 minus 70, which is 110, divided by 2, which is 55. And so that's 55 and that's 55. But we need to find a certain amount of this one here. So we need to find out what that one is. Now, so the way we're going to do this is the middle bit where this bit here, and this bit and this bit. So we're going to use this circle here to find out this information. And the way we're going to do this is we know that this is 35, we know that this is 35, and we know that this is 28. And we know that this is a quadrangle, or quadrilateral. So the sum of the angles in a quadrilateral is 360, and we're going to take away from that 70, 35 plus 35 plus 28, which is 98, and that gives us 262. So we know this angle here, this whole angle here is 262, and we know that this angle here is 98. Now we can use this piece of information, I really need a smaller thing, we can use this piece of information to now divide this down. So we know this is 98 because it's a vertically opposite angle, and we know that that is 196 from 360, which is 164, is that right? So that's 2, yeah, that's fine. And so that means these are 82 and 82. So, hang on, I'm just going to check I'm not being, yeah, no, that's fine. Now, so we've got that. Now, so that now means we know that in this, we know that is 82. And so we can use it on this one. So we know, using O, and this is X in the middle, OXD, we know that this is 70. We know that this is 82, I think. And that takes us to 152. So we know that this little bit here is going to be 28. And we know that the other bit of this altogether, that's 55. So 55 minus 28 equals 27. And that is how we find angle BCD. Now there might be an easier way, because looking at that, it does look as though BDC is is some sort of isosceles triangle, but I can't prove that immediately. That does use 3 of our circle theorems. So I hope that helps.